Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we're going to explore whether AI and AI development changes software fundamentals around work in progress and PR/MR merge size.
Okay. Yeah, it sounded like before the show you had kind of a story about this related to testing at your current company.
Right. Without going into specifics, or let's go into specifics, but also not. Uh, I'm working with a code base that is organically grown PHP from 2008, 2009.
Mm-hmm.
So if you can imagine, or you don't have to imagine, early PHP had a well-deserved reputation as a horrible language that lets you do horrible things.
Oh,
Uh,
yeah.
there's a wonderful meme, if you care to look it up, about if you had to you need to hammer something and you have a shoe and a glass Coke bottle, and what should you use? And this is an analogy for early PHP. If you had to use one of these two things to hammer a nail. And this code base has grown organically. So it's a real code base. It's really been running. And the
Mm-hmm.
developers have been writing unit tests in this thing for like 17 years. And
Ooh.
because of the way the early system worked, because of the way PHP worked, especially the early PHP, where you had globals were an extremely big thing. Like it would be hard to have an early PHP system that was not full of globals, session
Mm-hmm.
globals, global globals. And also, back in the prehistory of why they did it this way, they did it this way. It also has a persistent database that they use across the unit tests. And so
Ugh.
any test that didn't take a lot of effort to make sure it reset the persistent state back to the original starting state was quite likely to get tripped up on something else that some other system needed to set or unset. And so this system, it it ran in a certain order, and if you ran it in a certain order, everything was safe. And if you ran each test individually, it was safe. But you couldn't run some of the tests and have any confidence that a failure was actually a failure.
What was their rationale for the unit test slash end-to-end test bleed? Because usually with the unit tests, you want to isolate and mock like database calls, and you're just testing functionality and not like the response or whatnot. It sounded like they wanted to kind of hack the unit test to be end-to-end test in this case to make sure it modified state correctly.
Correct. These were more end-to-end tests. The rationale is that's what they did.
That's a good
There
rationale.
was no rationale. It just, or there may have been, right? Again, this is a 17-year-old code base. I have not been at the company for that long that it was
Yeah.
there, and things have inertia. So because the code base was set up this way, this is how testing was done. People just wrote more
Right.
tests, right? You could go back and invent an entirely new testing setup, testing harness, which we eventually did. Uh, they, because of the performance issues, we had what they were called slow tests, which are highly stateful end-to-end, more end-to-end tests than unit. And then we had fast tests, which were true unit tests.
I love
Everything
that
was mocked,
characterization. Yeah.
and it ran.
Okay.
So yeah, we did eventually, and by eventually I mean like 5 years ago, split out the the stateful end-to-end tests from the original tests. But because both exist, there are thousands of these stateful end-to-end tests that masquerade as unit tests, and developers continue to add to them because it's easy and it's better than not having them, right?
Fair enough.
Yeah. And so I asked myself, or my a colleague and I asked ourselves, could we fix this with AI? And the impetus for this was we have build pipelines, and the build pipelines, the spread between the fastest group of tests and the slowest group of tests was like 3.5 minutes. But we couldn't shrink the group. We couldn't reorder the tests because
Mm-hmm.
reordering the test wasn't safe. Everything would blow up. So, as an example, I naively, not naively, I had it just take. I had a AI say, "Hey, redo the sharding so that the tests are packed for time to limit the time spread between any of the shards, any of the
Ooh,
groups."
I can imagine it didn't do well for that first
Right.
pass, depending on how you prompted it.
Well,
Yeah.
there were 32 shards. Then they all passed, right? Because all the tests pass if you run them in the right order, and they all pass
Mm-hmm.
if you run them individually. 32 shards. I had it repack it for time, and all 32 failed. And so we had AI. We're like, okay, well, here's all these failures. Look at these failures. These are all due to leaked state. And so it was like, okay, have all of these tests, reset the state that they need on setup, and then try to have it clean up the state at the end, right? So don't leak more. And so 30 or 40 merges later, we got them all. It was more like 50. Got them all
Mm.
working. And I said, okay, cool. Are we really done though? Shuffle it up again. And that time, like 18 of the suites
Nice.
failed.
Yeah. Okay.
And so we continually did this. And after about 100 after about 100 MRs, each with one or two test files in each MR, I said, okay, maybe we're going about this the wrong way. Instead of trying to fix each test individually, let's have it do a blanket thing. Right. And I should say, I had it trying to fix all these things individually because I was going at it in a break fix manner of this is broken, fix it, and do lots of small things and then merge it
Yeah.
in. I'm like, okay, well, what if I tried to have the AI be proactive? I said, okay, look, analyze these things. Like here, this is PHP. Look at the session object, look at the global object, look at these things, look at these database things, the dependency injector. These are the stateful things that exists in this test suite. Look at all the tests, find things that get changed and don't get changed back, and then come up with a list. And then let's change all the, set up all the teardowns to fix all of those things. And then it'll be great.
Mm.
Eh,
I was going to say, I'm just going to. So the main problem here is just the fact that the suite takes a long time to run, and
mhm.
changing the order of these tests to optimize for the time is risky to do. So the process here is essentially just trying to train the AI to most effectively order these tests for you. So your initial prompt was something along the lines of, we know these things are stateful based tests,
Mm-hmm.
and that when we change them, they'll break. Organize them. And so it did a decent first pass after, well, not first, but 50 passes, MR passes. After that, it was able to make the test suite faster, essentially. It was able to make them all, every test pass, and the suite was faster. But you were like, is this a hardy solution? Are we going to run into this problem again? Is that the main reason why you kept going?
Correct. Right. We had a system where, yes, we had this test. You could run them in this order. And then if we shuffled them, we could make the build process like 25, 30% faster on every build simply by changing the order the tests were run. And so we changed the order and then we fixed all the things that were broken. But as soon as we started adding new tests, this problem was likely to crop up. And this has been a ongoing problem with this code base for as long as I've worked there of, oh, you added some tests, some of these integration tests, and now suddenly this other test that is totally unrelated doesn't work anymore because because your new test shifted the ordering and now this test doesn't work. And when you fix that test, it can cause a new cascade of other failures. And so this is a perennial developer problem, right? Not only is this...
I got a question then for your, as you started talking to the AI and trying to come up with some solutions for this, did you get curious about, like, maybe I can just randomize every time the test suite runs, like tell it, I want you to run the test suite 5 times before you say it's good. And every time you run it, I want you to run it in a random order, like order all the tests and then just shuffle them every time or something like that to kind of give it a test or something to play with?
Yes. So we set up a second branch, right? So we set up the first branch was we want this to be as fast as possible. We want the build to be as fast as possible.
Okay.
We set up a second branch that was we want you to run the test in as random of an order as possible.
Nice. Okay.
We never had to run that second branch twice to get a new bunch of tests that were failing. Every
Oof.
time we
Okay.
ran it randomly, we got failures. And so we would fix those failures. We didn't need to run it 5 times and just
Did you have like AI run it and like expand like its thinking process, and like did you see that it was going, I've run into this failure again after only the second pass, and like see how it like how it tried to change its own behavior to run to change how it's running the tests? Because sometimes I've noticed like I can see what it's thinking if you expand the window depending on the
yeah.
model that you're using, and then so if you only had to run it twice, the chore is almost to give it to it and be like, run it 5 times and come back to me if all 5 ran successfully. If not, find out why, and then just kind of like watch it and see what it's thinking and why. Like usually you'll see one area where it's like, again, I failed the task. Let me see if I can change this so that something else happens, and you just kind of sit there and watch it. Have you tried that?
No. So that's where I was going with for this thing and the best practices, right? Because we could have
Mm-hmm.
done that. We could have said, hey, AI, right, it's totally random. It's gonna shake it's gonna shake the snow globe and things are gonna fail. And I want you to shake the snow globe, then fix all the failures, then shake the snow globe, then fix all the failures, and keep going until you can shake the snow globe like you said, 5 times. Uh, but what I realized, and again, this is my decision as a human developer, is when I had it come up with a list of all the things that we need to change, after right, we were at least 100 merges in, and I said, okay, come up with a list of all the things that you would need to change to be fairly confident that you were not leaking state. And it was more than 400 things,
More than 400
400 test classes.
test classes. Okay. Is
Right.
that a
So
bad thing?
no,
It's a
but
big thing.
it's a big thing. But if I did the snow globe thing,
Hmm.
right, I said, shake this thing, fix the test, I would be left at the end, ignore whether or not that was an efficient use of my tokens. I would be left at the end with 400 changed files and a green build. And I would have
Okay.
no idea. Like, I guess I could merge it. No, I would have no idea about what had changed.
Ah, and now we're back to the other problem from a past episode, which is, when you really let AI build everything for you, um, and review everything for you, at some point you might not know how any of this is even working anymore. And so if you want to keep understanding how things are working, in your case here, you have to go in those. This is what you're getting at, I guess, is the smaller pieces. You can't approve 400 tests at once, even if it looks green, because you don't know if some of those are false positives or if they've changed some kind of thing to make it pass because it gets clever because it wants it to pass for you too.
Right. Yeah.
You
It
know,
could pass. Um, Things that we've noticed when we were working with doing it one off at a time. Again, this is an organic PHP code base.
hmm
There were 4 flavors of database operations. There's the very low level. Here's PDO, do the database thing, and then there was the homegrown ORM, and there's Laravel.
man,
Uh, Sorry, there's three variants of homegrown ORMs plus Laravel, and it would get confused. It would start writing PDO, or it would start using Laravel in
yeah,
sections of the code that don't use Laravel, and that would work, right? There's nothing fundamentally wrong with, okay, I'm going to use
hmm
PDO and have it write raw SQL to reset state.
yeah.
But like, that's not idiomatically correct. You're just making the whole thing slop.
And that honestly is another good call out too. Is that confuses human and AI when you do unconventional things, which tend to happen if you built a library before another library got famous and big.
Mhm.
Or like at one company I worked at, they had built their own test framework, and it was after PHP Unit. This is PHP. It was after PHP Unit existed, but they made their
Mhm.
own assert true, assert false, assert equals. Their whole library. They had. I have no idea why they built their own custom one. But anybody looking at that thinks, oh, this is just using. It was the exact same format as PHP Unit test suites, and I was like, well, this is not even using that. This is, and I had to fix a bug in their test suite for like equals operators, right? So when you let AI loose on that too, it also gets confused because it makes the same assumption that humans do, that oh, this is using a very popular framework and it might not be. And then separately, another issue we saw was like if you
Well,
end
I
up
did
using,
see,
go ahead.
yeah, like it's for one of them, it made its own comparison thing. I'm like, I looked at the MR, I'm like, why is you not just using assert?
Right. It'll do anything it can to make it pass. So you have to be careful. Um, but yeah, using conventions, I think is even more important these days for the sake of AI, because you'll confuse it. And one other thing before we get back to the test topic, I happened to notice this recently, is there was this really weird flow at a company I'm working at where we would mark something as like a bill as paid, and we would say paid is true, like a Boolean. And we had this other flow where we wanted something to be not showing in our main portal, but showing for partners. And so we'd mark it as paid to hide it from our portal, but then have a not paid, another not paid column, and then another like I forget this other column we used to show it in the partners panel, so they could continue operating on a bill that looked like it was paid from our end. So whenever AI hits it and it was like, no, this bill's already paid, we're like, no, that's just not, it's actually elevated to the partner technically, but it's still not actually paid. It's just paid true
Right.
does not mean
This
it's
is
truly
very
paid.
enterprisey. You have a Boolean and now you need
Yeah.
another one. So you add a second Boolean. Now you've got four
Yes.
states, but two of them
And
are invalid.
AI was confused by this. I mean,
Yes.
because we are too. Any junior engineer coming in and looking at how you've set it up goes, wait, what? Because it doesn't really make sense. If paid true doesn't mean it's actually truly paid, that's confusing. And so AI will run with that too. So back to the testing conversation, that those conventions are super important. And I think maybe, and this is what I've been trying to do recently too, is clean up around language that we're using at our companies, and
Mhm.
especially clean up on dead files that provide context to AI that it does not need, that might confuse it, is becoming more important for us too.
Yes. So yeah, to bring it back to the question that we were talking about at the beginning, my partner, my colleague and I started this project, and we've merged 200 changes to the test suites,
Mm-hmm.
and we think we're getting close to being done. But the main thing, one of the things that's happened is we have merged 200 times into the main branch. Like, we don't have this giant 200, 300 file WIP out there, with all this
Work in
theoretical
progress.
value.
Yeah.
Yeah, work in progress. Everything we've done immediately got merged back in.
Mm-hmm.
And so we
Good.
know that none of these things broke anything. We also, because we kept the humans in the loop, we know that the changes are reasonable. But also importantly, like, one thing that we noticed, because when we went back to look, like, okay, we're getting close to the end. Let's make sure we have numbers to talk about, right? Because, like, okay, there's a 3.5 minute spread between the fastest and the slowest. One thing that we learned when we went back to look at the numbers is, oh, that spread has shrunk to 90 seconds. It's only a minute and a half now, because developers have been continuing to add tests. We've been doing things to cause, so even on the main branch where we have not intentionally caused a reordering has happened, but there was no cascade of side effects, which normally happens when that happens.
Yeah.
And so even though the project is not done, and even though we haven't gotten the goal that we hit going for, which is to make the build faster, we've already, because we kept merging everything as we went along, we've had this benefit, this silent benefit of,
Yeah.
and we've quieted down the random disasters of flaky tests showing up.
Nice. So what's the end goal at this point? Like, at what point, or would you call your project finished? Because I imagine like there's only so much you're going to get diminishing returns at some point.
Right. Yeah, we have not done the snow globe, although maybe at this point we should do the snow globe because now it's small enough. But our current thinking is when we get the current round done so that the build is green again, we'll get the 90 seconds, we'll declare victory, and maybe
Mission accomplished.
mission accomplished. Maybe we will set up something in the background to snow globe and see if we can get it to snow globe, but also, fix this test. I guess there's no reason it still wouldn't have to, because I would still set it up. I would have it snow globe, right? Here's shake it, fix these things. And then when you fix the test, cherry pick, create a new branch, cherry pick that and build and tag me with a new thing so we can merge that change back in.
So I'm going to ask an evasive question. Is there a possibility that the tests are just written in a dumb way, or that the unit tests that we've made into end-to-end tests, maybe because you said people kind of took that and ran with it and then just made their own tests. I assume, maybe wrongly, that somebody decided to do this database state test on something that's actually quite simple and didn't even need a database. They just kind of did it because that was the pattern everyone was doing it for. Is there any way to clean up just the test styles themselves so you don't run into the state problem as often? Or maybe extract some of the happy path tests to make sure you got decent coverage, but you don't need it for everything? Or has that already been considered?
I already considered it and I already did that. So a few months ago, an earlier version, before I realized that there was such a large spread between the slow test suites themselves, I said, well, what if I could extract some of the slow tests that are not actually slow, that aren't, stateful, and move them over to the fast? Because the fast test suite runs in like 30 seconds. It's fine. And so I did. I got 1 or 2% of the tests. And again, I used AI. I had just had to move it over, boop, from slow to fast. And then I had to fix some stateful cascades because I removed tests, which caused the orders to shift. So yes, I did that. I anything that didn't actually need state has been moved from one side to the other, which also got a small. It took a few seconds off the build time because it no longer was setting up state and trying to reset the state and doing all that stateful work for tests that didn't need the state at all.
Okay. Evasive question number 2. Are there any tests that you found that you could have just plain out deleted, like where they were actually already encompassed by another test that did the same kind of or similar work that already proved what a smaller test was doing that you could have deleted?
We didn't ask the question. I thought about it, but I didn't want to. I don't have enough confidence that I would trust the AI's judgment on it, and I didn't want to spend the time proving it to myself. And so sort of
Fair enough.
letting the
Yeah, okay.
sleeping dog lie. And I feel like I would have more confidence if it was a fresh system as opposed to one that has grown organically for
Yeah.
almost 2 decades with,
Yeah.
many styles and many things.
Yeah, I think the way you approached it is kind of the way I approach it. Is like essentially I call it the lazy approach. At first, you're like, "Do we have to do this?" And after we have to, if we know we have to do this, okay, well, do we have to do all of it? And then just kind of keep breaking it apart there. And then when you're finally left to actually, we have to solve this problem, and there's not a way to simplify it any further than that. All right, well, let's get to work. And then from there, going through and finding ways to shake the snow globe or improve the process and the bootstrapping, whatever we need, until we get the problem solved. So I dig it, and the smaller delivering in smaller chunks too, especially because I know at the company I'm at today, a 400 test change is not something people would just blindly approve yet. People are getting too hasty with AI, but usually that's like, this is too much. This is too much to change. We don't know how it works. And then you'll go through, like you're talking about, and you'll find, oh, you just wrote your own definition of assert equals, and that's how you got it to pass. Come on, and AI it'll still cheat and get clever. And so having some kind of double check to make sure it's not doing that, or that your test is actually doing what you need it to be doing, is still important, and it's still something AI is not really reliable on yet. It's getting better, but it's still not reliable.
Right. And there is something to be said for, hey, it's just a test. It doesn't really matter if it's, but if it's not actually testing what you think it is, then it
Yeah.
matters.
Yep.
Awesome.
All right.
Well, we actually ran long. Thank you all for listening. I'm Jeffrey Sherman.
And I'm Isaac Askew, and this is Never Rewrite.